Hello everyone, I hope you all are doing fine. My name is Moinak and this is the part 2 of a two-part series of a fully solved Wbpsc Assistant Engineer Civil 2016 paper, and I have tried my best to solve most of the questions to the best of my ability. And without wasting any time, let's start the video. So the ideal shape of a transition curve is a clothoid. So remember this, the ideal shape of a transition curve is a clothoid. Next question, a beam curved in plan is designed for. A beam curved in plan is designed for. The answer would be bending moment, shear force as well as torsion. So if a beam is curved in plan, it is designed for all three, bending moment, shear force and torsion. The next question is, an increase in temperature on the top fibers of simply supported beam will cause. Now if this is a simply supported beam and the temperature of the top fibers are increased, then it would try and expand, right? So if this expands, the deflection would be somewhat like this. So the deflection should be in the upward direction. So an increase in temperature on the top fibers of a simply supported beam will cause upward deflection. Next question is, which of the sections should be used preferably at places where torsion occurs? The answer for this particular question is a box section. Which of the sections should be used preferably at places where torsion occurs? Answer should be a box section. Next question, for two-way RC slab, the deflection is guided by short span. The deflection is always guided by the short span. Remember this, the deflection is always guided by the shorter span. Next question, the eccentricity of a circular column of external dia 25 centimeter, internal dia 15, for a eccentric load of 1000 kilonewton for no tension condition is. Now you can directly apply the formula in this particular case. The eccentricity is given by inner dia square plus outer dia square by 8 times the outer dia. So you just replace the values over here, and the answer would come out to be as 4.25 centimeter. So the answer for this is 4.25 centimeter. Next question is, in a rectangular channel of constant width, water flows at subcritical state. At a place where there is a local rise or hump in the channel floor, the depth of water over the hump will be. The answer for this particular question would be lesser than the upstream depth. Now remember this, if the approach is subcritical, where the Froude number is less than 1, it will have the water level would decrease at the hump. The water level would decrease at the hump, and if it's a supercritical approach where the Froude number is greater than 1, it will cause an increase. The water level will increase at the hump. So remember this. The next question is, the most essential condition for a hydraulic jump to form is. The most essential condition for a hydraulic jump to form is, the answer would be the existence of supercritical flow before the jump. The existence of supercritical flow. This is the most important condition for a hydraulic jump to occur. Remember this, before the existence of a supercritical flow before the jump. The next question is, the shear stress distribution in viscous fluid through circular pipes. Now the answer for this particular question is, it is maximum at the inside of the surface. Now let's see, this is actually the shear stress distribution of circular pipes. As you can see, it is maximum at the inside surface and minimum at the center. The another question can be asked from here is, what is the velocity distribution type and where is it maximum? So this is a parabolic. This is parabolic in shape. This is parabolic in shape, and it is maximum at the center, and minimum at the surfaces. Next question is, the most essential condition feature of turbulent flow is. The most essential feature of turbulent flow in pipe is large discharge, high velocity at point remains constant. None of these. Velocity at and pressure at a point exhibit irregular function. The answer fluctuation. The answer would be velocity and pressure at a point exhibit irregular fluctuation. The answer would be D. Now the next question is, cavitation in fluid flow occurs when? Cavitation in fluid flow occurs when the pressure of a flow decreases to a value close to its vapor pressure. The answer would be A. The pressure of flow decreases to a value close to vapor pressure. Next question, a slope is to be constructed at an angle of 30 degree to the horizontal for a soil with C equal to 15 kilonewton per meter square, phi 22.5 degree, gamma is 19 kilonewton per meter cube, and Taylor stability number is given, and also the factor of safety is given. Now you need to find the safe height. Now, stability number is given by C by F naught gamma h. So h is the safe height here. You just need to replace the values where 15 is the cohesion value, 1.5 is the factor of safety, 19 is gamma, and stability number is 0.046. So the answer, the safe height would come out to be as 11.44. So the nearest answer in this particular question would be D, 11.5 meters. Now the next question, right deflection angle may be directly obtained by setting the instrument to read. Now the answer would be 0 on backstation. This is from theodolite surveying. Theodolite surveying. So right deflection angle may be directly obtained by setting the instrument to read 0 on backstation. The next question, rich mortars are more liable to cracking as compared to lean mortars because rich mortars have A, high shrinkage, B, less strength, C, both A and B, and D is none of the above. The answer would be high shrinkage because rich mortars do not have less strength, they have high strength. Why does high shrinkage occur? Now rich cement mortars, they have a high cement content, hence the shrinkage is more. So you know that if the cement content is more, the shrinkage of that particular mortar would be higher. Next question is, while doing leveling in undulating terrain, it is preferable to set the level on. The answer for this particular question would be any side of the slope. So the answer for while doing leveling in undulating terrain, it is preferable to set the level on any side of the slope. Next question, height of instrument may be defined as height of instrument at the time of observation, the elevation of the plane of collimation when the instrument is accurately leveled. This seems the right answer. Height of instrument if backside distance equal to foresight distance. So the answer should be B, the elevation of the plane of collimation when the instrument is accurately leveled. Also, height of instrument is given by RL of benchmark plus the backside reading. The next question, for earthquake resistant masonry buildings, the vertical distance between opening one above the other in a load bearing wall shall not be less than. The answer for this particular question is 60 centimeter. Now, if a question like this comes, most of the students won't be able to answer this particular question, and you don't need to worry about questions like these because most people won't be able to answer it in the examination hall. It is very difficult to memorize everything from the codes, so don't worry about questions like these. These are just there so that you can't answer these particular questions. Now the next question is, newly constructed pavement with ordinary Portland cement attains its working strength after. For OPC, the number of days after which it attains the working strength is 28 days, and for rapid hardening cement, which is mostly used for constructing pavements, it attains its maximum strength in 7 days. Because you don't have so much time to construct roads, because you are blocking a particular section and you are diverting traffic, so you don't have much time. So mostly rapid hardening cement is used, but for OPC, the number of days in which it attains its working strength is 28 days. Remember this. Next question is, in waterbound macadam roads, binding material is. So for waterbound macadam roads, the binding material is stone dust. For waterbound macadam roads, the binding material is stone dust. Now, next question, the maximum number of passenger cars that can pass a given point on a roadway during 1 hour under the most ideal roadway and traffic condition is. Now, if this word is there, ideal, the answer would be basic capacity. If instead of ideal there is prevailing conditions written over here, the answer would be possible capacity, right? So this particular question, the answer would be B, basic capacity. And what is practical capacity? Practical capacity is the design capacity. So the maximum number of passenger car that can pass a given point on a roadway during 1 hour under the most ideal roadway and traffic conditions is known as basic capacity. And instead of ideal, if they give over here under prevailing conditions, then the answer would be possible capacity. And also possible capacity varies from 0 to basic capacity. Remember this, it varies from 0 to basic capacity. Next question, CBR, California bearing ratio method of designing flexible pavements is more accurate as it involves. The answer for this question would be character of road making materials, because it involves the characteristics of road making materials. Also, there are a few particular things that you need to know about the CBR method. CBR value is actually the maximum of The CBR at 2.5 millimeter penetration and the CBR at 5 millimeter penetration. Generally, CBR 2.5 is greater than CBR 5. So if the CBR 5 is greater, then the test should be repeated again. And if similar trends follow, like if CBR 5 is greater than CBR 2.5, then after the test has been repeated, the CBR 5 value is taken. Now the standard loads at 2.5 millimeter and 5 millimeter penetration in kilogram is 1370 and 2.2055 kilogram respectively. So remember this also. They might ask you questions like what is the standard load at 2.5 millimeter penetration. The answer would be 1370 kilogram. And also this is the graph between the load and penetration. This is the CBR graph. This should be convex throughout. If you have any concavity in the curve, you should repeat the test again. If you have any concavity in this particular graph, you should repeat the test again. Now the next question is, if there is rain between 8 a.m. to 10:30 a.m. and the entire basin just starts contributing water at 8:30 a.m. to the outlet, then the time of concentration will be. Now the time of concentration is given as the starting point of rain, that is 8 a.m., and the time at which the entire basin just starts contributing, that is 8:30 a.m. So deduct the time between 8:30 and 8 a.m., that is 30 minutes. The time of concentration is given as the time when the rain starts and the time when the entire basin starts contributing water. Next question would be, dead storage of a reservoir is provided to meet emergency needs, no. Mitigate floods, no. Accommodate silt entry, yes. So the answer would be accommodate silt entry. So dead storage of a reservoir is provided to accommodate silt entry only. The next question is, to prevent sloughing of an earthen dam, it is necessary to provide. Now to prevent sloughing of an earthen dam, it is necessary to provide riprap. It is necessary to provide riprap. Next question, river training works primarily to protect river is. The answer would be groins. River training works primarily to protect river bank is groins. Now this is an attracting groin. How would you know if it's an attracting groin or a repelling groin? The pointing face is towards the downstream side of the river. This is the upstream side and this is the downstream side. Now the pointing face of the groin, if it's in the downstream side of the river, then it is a attracting groin, and if it's in the pointing side, if it's in the upstream side of the river, it is known as repelling groins. Now attracting groins, they attract stream flow towards themselves, and repelling groins, they repel water flow towards the bank. Also marginal bunds. What are marginal bunds? These are used to prevent flooding on the upstream side of the river. Marginal bunds or marginal embankments. Next question is, ductility of a flexural member reinforced concrete can be increased by. Uh, Now increasing percentage of tensile reinforcement, no. Decreasing percentage of tensile reinforcement. The answer would be decreasing percentage of tensile reinforcement. So the ductility of a flexural member can be increased by decreasing the percentage of tensile reinforcement. Next question is, the closure of valve is considered rapid. The closure of valve is considered rapid when the valve is. Now the closure of valve is considered rapid when the time of opening the valve is less than 12 by C. The time of opening the valve is less than, this would be the duration closure is greater than close equal to, the answer would be duration of closure is less than 12 by C. So the closure of valve is considered rapid when the duration of closure is less than 12 by C. Also for gradual closure, it should be greater than 12 by C. Now Terzagh's bearing capacity factors are function of Terzagh's bearing capacity factors. Now this is the ultimate bearing capacity formula. It is given by CNC plus gamma DF NQ plus 0.5 B gamma N gamma. Now these are the bearing capacity factors, NC, NQ and gamma. Now these are only functions of phi. These are only functions of phi and nothing else. So these are the formulas of finding out the NC, NQ and N gamma. So as you can see, phi is the only factor in which it is dependent. So the answer for this particular question, Terzaghi's bearing capacity factors are functions of phi only. Now the critical height of an unsupported vertical cut in a cohesive soil. The answer for this particular question would be 4C by gamma root K or 4C by gamma tan 45 plus 5 by 2. Now the depth at which earth pressure becomes 0 in case of cohesive soil is given by ZC, which is 2C by gamma tan 45 plus 5 by 2, and the depth of unsupported vertical cut is given by 2 times this depth. So the answer would be 4C by gamma tan 45 plus 5 by 2. Now the soil has bulk density of 1.8 gram per cc at a water content of 5%. If the void ratio remains constant, then its bulk density for a water content of 10% will be. The answer for this particular question is, as you know, gamma D is equal to gamma bulk by 1 plus water content. Now just use this formula and find out the gamma D for the first case. So just replace the values of 1.8 and 1 plus 0.05. The answer would be 1.714 gram per cc. Now you need to find the gamma bulk of the second part. So the gamma D would be the same. The gamma D would be the same. So replace this value over here. Replace this value over here and find out the gamma bulk of the second situation. So the answer over here should be 1.8 gram per cc. Just replace the values and you would get the answer yourself. So the answer for this particular question should be B, 1.8 gram per cc. Next question is, for a sandy soil, the angle of internal friction is 30 degree. The major principal stress at failure is 50 kilonewton per meter square, and then the corresponding minor principal stress in kilonewton per meter square. Now you know the major principal stress sigma 1 is equal to 2c tan 45 plus 5 by 2 plus sigma 3 tan square 45 by 45 plus 5 by 2. Now this is the minor principal stress. Since this is a sandy soil, this part C becomes 0. So you just replace the values. 50, which is the major principal stress, is equal to sigma 3 tan square 45 plus 5 by 2, where 5 is 30 degrees. So tan square 60. So the answer comes out to be sigma 3 is equal to 16.66 kilonewton per meter square. The next question is, Taylor's stability number is given by. The answer is very simple. Taylor's stability number is given by this particular formula, C by F naught gamma H. C by F naught gamma H. Next question, if a sample of dry sand tested with direct shear test gives failure shear stress as 100 kilonewton per meter square at normal stress uh, of 200 kilonewton per meter square, the angle of internal friction would be. Now just plot the graph of this particular question. This is the shear stress and this is the direct stress. Just plot the graph, and this is the phi. This is phi, which is the angle of internal friction. Now you can know tan phi. Tan phi is given by the slope. Tan phi is given by the slope of this particular graph. So just find out the slope, or you have a direct formula for this particular question. Tau is equal to C plus sigma tan phi, where C is 0 in this particular case and phi is tan inverse of tau by sigma. Tau is 100. Tau is 100 over here in this particular question and sigma is 200. So the answer would be tan inverse of half. Tan inverse of half. The next question is, under load, the void ratio of a submerged saturated clay decreases from 1 to 0.92. What will be the settlement of a 2-meter thick clay of same type due to consolidation? Now you have a direct formula for this. The settlement is given by delta E by 1 plus E naught into H. Now delta is nothing but the difference between the initial void ratio and the final void ratio, which comes out to be 0.08, and you just replace the values in this particular equation and you get the answer. Sigma H is 0.08 meters or 80 millimeters. So the answer for this particular question would be D, 80 millimeters. Next question is, the bearing capacity of a strip footing resting on a saturated clay is 120 kilonewton per meter square. The bearing capacity of a circular footing with diameter same as the width of the strip of footing resting on same soil would be more than 120, equal to 120, less than 120, or any of the above. Now bearing capacity is given by, the ultimate bearing capacity is given by CNC plus gamma DF NQ plus 0.5 B gamma N gamma for strip footing, and for circular footing it is given by 1.3 CNC plus gamma DF NQ plus 0.3 D gamma N gamma. Now B and D are equal, which is given in the question. Now for cohesive soil, phi is 0. For cohesive soil, phi is 0. So for phi equal to 0, the NC values is 5.7, NQ is 1, and N gamma is 0. So this particular part is out of question. So the parts which are important are this. So as you can see from the equations here, this has a multiplication factor of 1.3. So for circular footing, this should be more. This should be more. So the ultimate bearing capacity for circular footing with other things remaining same would be more than 120 kilonewton per meter square. Now moving on to the next question, a cantilever beam is subjected to a UDL W. UDL, it is actually given by this omega or whatever you can call it over its whole length L and a concentrated load W at free end. The deflection and free end is. Now you can use the superposition principle here. You can use the superposition theorem here. Now this is the diagram that they have given you. This is the uh, problem that they have given you. There is a cantilever beam and you have a UDL over here and a upward load in this particular direction. So consider the deflection in the downward direction as positive and the deflection in the upward direction as negative. So you just break these into two parts. So just a cantilever beam with UDL and a cantilever beam with a upward load W. So for the first condition, the deflection is given by WL to the power 4 by 8EI plus this. For the second condition, it is given by WL cube by 3EI, which is in the upward direction. We have considered upward direction as negative, so that would be a negative sign. Now the total deflection would be this. We have changed the small w or omega as w by L, replaced it by w by L. So WL cube by 8EI minus this minus sign because it is in the upward direction, WL cube by 3I. So the answer should be minus 5WL cube by 24EI or 5WL cube by 24EI in the upward direction, because we have considered the deflection in the upward direction as negative. So the answer should be C. So the answer should be 5WL cube by 24EI. The next question is the latest start of an activity is always. The latest start of an activity is always. The answer should be greater than equal to latest event time of preceding node, less than or equal to latest event time of preceding node, no. Equal to latest time of preceding node, no. Less than the latest time of preceding node. The answer should be greater than or equal to the latest event time of preceding node. The latest start of an activity is given by greater than or equal to latest event time of preceding node. Next question is what is the resultant noise level generated simultaneously by two sources with same intensity of 90 dB respectively. So if you have a question like this, you have a direct formula. You have a direct formula of Le cube is equal to 10 log 10 to the power L1 by 10. Here L1 is 90 and L2 is also 90. Just replace the values, you would get the answer. If you don't remember this formula, there is a chart that you can follow. If the difference between the two sound levels are 0 to 1, then you can add 3 to the higher value. If the difference is 2 or 3, you can add 2 to the higher value. If the difference is 4 to 8, you can add 1 to the higher value. And if the difference is greater than 9, greater than equal to 9, then you don't have to add anything to the higher value. So you can remember this chart so that you can solve these kind of equations, these kind of numericals very easily. Next question is alum acts as a very easy question. Alum acts as a coagulant and not a flocculant. Remember, alum acts as a coagulant and not a flocculant. Next question, maximum super elevation on hill roads should not exceed. For hill roads, it is 10%. For urban roads, it is 4%. And for plain and rolling, it is 7%. So remember all three. Next question, Imhoff tanks are used for removing. The answer would be organics. Imhoff tanks are used for removing organics. Pick up the correct statement from the following. Braking distance is given by v square by 250 mu. Reaction distance is given by 0.28 vt. Stopping distance is given as a plus a and b. The answer should be all of the above. The answer should be all of the above. I have given you a diagram. This is the point where the driver actually sees the obstruction. This is the obstruction and this is the total available distance for the driver to stop before a collision. So this is the lag distance where the driver sees the obstruction and actually applies the brake. So this is known as the lag distance or the reaction distance, and where driver applies brakes till the vehicle actually stops, this is known as the braking distance. So it is denoted by LG and LB respectively. So LG is given by 0.278 Vt and LB is given as V square by 254 mu, and the stopping side distance is the addition of both of these. So according to the answers that are given here, the options that are given here, the best possible answer is D, all the above. Now the next question is the extra widening of pavements recommended by Indian Roads Congress for hill roads having 150 meters is. Now from IRC 73 1980 table 18, The radius of curve when it is from 100 to 300, 101 to 300 meters. For single lane roads, the extra widening provided is 0, and for two lane road it is 0.6. So I would assume, or you should also assume, that the question that they have asked is for single lane, so the answer should be 0 here. The answer should be 0 here. Also, extra widening is given by NL square by 2R plus V by 9.5 root R, where NL square by R is the mechanical widening. This is the mechanical widening, and this is the psychological widening. This part is the psychological widening. Also, where n is the number of lanes and L is the standard length of vehicle, which if not given can be considered 6 meters. Also, extra widening is provided only on the inner side of hill roads, is only provided in the inner sides of the hill roads. Next question: if the depth of water at any section is if x is the depth of water at any section, then the mean velocity is. The answer for this particular question is 0.6x. This is from hydrology. So if x is the depth of water at any section, then the mean velocity is 0.6x. Now ABCD is a rectangular parallelogram plot of land whose angle BAD is 60 degree. If the bearing of line BC is 30 degree, then the bearing of the line CD is. Now this is the rectangular parallelogram that they have given. This is the point A, and BAD is 60 degree. BAD is 60 degree as mentioned here. And if the bearing of the line BC is 30 degrees, BC is 30 degrees that I mentioned here, the bearing of the line CD. So the one marked in the angle marked in red is to be answered. Now you know, for a rectangular parallelogram, this opposite angles are equal. For a rectangular parallelogram, so this should also be 60 degrees. And you know the back bearing of BC is given by 30 degrees plus 180 degrees, which should be 210 degrees, 10 degrees. So this should be 210 degrees. So the bearing of line CD, the bearing of the line which is this, the bearing of the line CD is nothing but 210 degrees plus 60 degrees. So the answer for this particular question should be 270 degrees. D. The answer should be 270 degrees. The next question is, which one of the following influences the geometric design of highways? Now, it is dependent on the radius of highway curves, width of pavement, as well as parking geometrics. So all of the above would be the right answer. And the most important factor for geometric design is the design speed. Remember, the most important factor is the design speed. The next question, if delta is the angle of deflection of a curve, T1 and T2 are the points of triangles. The angle between the tangent T1 and T2 are the points of tangents rather. T1 and T2 are the points of tangents. They should be tangents. The angle between the tangent at T1 and long chord T1, T2 will be. Now this is a simple curve T1, T2. Now this is the angle marked in red. They want to ask you what should be the angle. Now for simple curves, you should remember some points. T1 is the point of curve, T2 is the point of tangency, I is the point of intersection, and AT1 is known as the back tangent, and T2b is known as the forward tangent. Also C is the center of curvature of a simple curve, and T1 T2 is the long chord. So let's calculate the angle between this particular line, that is T1I, and T1 T2. We are required to solve this particular angle. So as you can see, this is the intersection angle, this is the deflection angle rather, delta. This is the deflection angle delta. So this angle should be 180 minus delta. This angle should be 180 minus delta. If this angle is 180 minus delta, this angle should be delta. If this angle is delta and this is the bisector of this particular angle, this particular angle should be delta by 2, right? And this is also delta by 2. Now this is 90 degree, this is delta by 2, so this angle should be 90 minus delta by 2. If this is 90 minus delta by 2 and this is 90, so this angle which we are required to find should be delta by 2, right? Should be delta by 2. So the answer for this particular question is the angle between the tangent at T1 and long chord T1 T2 should be delta by 2. The answer should be delta by 2. Also they sometimes ask you what is the tangent length in terms of formula. The tangent length is r tan delta by 2 and length of long chord is given by 2r sine delta by 2. The next question is, premature aging of plants occurs due to. Now the premature aging of plants occurs due to ozone. The premature aging of plants occurs due to ozone. Now, two specimens of clay A and B are tested in a consolidation apparatus where MV is nothing but the coefficient of volume compressibility and CV is nothing but the coefficient of consolidation. Then the ratio between permeability of A and permeability of B will be equal to. Now, there is a simple formula for coefficient of consolidation which is given by K by gamma W MV, and therefore K is equal to CV gamma W MV. You just need to replace Ka and Kb with the numericals with the values that are given here, and you would get the answer as 4. Very easy question. If you know the formula, it's a very easy question. So the answer for this particular question should be 4 according to me. Next question is 100 question is, if RL of a benchmark is 100 meter, the backside is 1.215 meter and the foresight is 1.87 meter. The RL of the forward station is. Now you know height of instrument is given by RL of benchmark plus the backside reading. So the RL of benchmark is given as 100 and the backside reading is 1.215. So you just need to add it, 100 and 1.215. And the RL of forward station is given by RL of forward station is given by 101.215, that is the height of instrument minus the foresight reading. Is 1.870. So the answer for this particular question should be 99.345 meters. The answer for this particular question should be 99.345 meters. The answer should be A according to me. Also, in the last video that I've provided, I made a mistake in terms of in question number 4. Side face reinforcement in reinforced concrete beam is to be provided for. The answer that I gave you all was A. Total depth of beam should be greater than 750. The actual answer should be B. The depth of web of beam should be greater than 750 millimeter. This is according to the clause 26.5.1.3 from IS 456. So I made a mistake here. The total depth of web of beam should be greater than 750 millimeter in this particular case. Remember, if this option is not given, then this is the right option. But since this option is given, it is specifically mentioned as the depth of web of beam is greater than 750. You should answer this question. This is the right answer for this particular question. So this is the part 2 of a 2-part series of Wbpsc Assistant Engineer Civil Examinations in the year, which was held in the year 2016. I hope the question solving helps you prepare in a better manner for the assistant engineer examinations. I wish you all the best and stay safe, all of you. Study hard but study smart. Thank you.